Welcome to We Learn. This is session 6, part 1 on software quality and testing. On the unit is test case design. In this session, we are going to cover topic testing techniques, white box testing, basis part testing, flow graph test notation, independent program paths, cyclomatic complexity, driving the basis set and test cases, a second flow graph example, the loop testing, and identifying the different algorithm paths. Now, I would like to give you basic introduction about the testing that software can be tested either by running the program and verifying each step of execution against accepted the results are by statically examining the code or the document against its stated requirement or objective. Here, in the journal, software testing can be divided into two categories. That's by static and dynamic testing. Static testing is non-execution based testing and carried out by mostly human effort. And in static testing, we test design code and many documents through inspection and walkthrough as in previous session we studied. And the many studies that's now single most cost effective defect reduction process in the classic structural test. Here the code that inspection or walkthrough. Now the code inspection is likely proofreading and developer will be benefited in identifying the typographical error, logical errors, and deviation in style and standard normally followed. Dynamic testing is basically execution based on testing technique. Program must be executed to find the possible errors. Now, in the front of you are the two ways and technique through which we can do testing is the black box testing and the white box testing. Black box testing is the knowing the specified function that a product has been designed to perform tests to see if that function is fully operational and error-free. Include tests that are conducted at the software interface and not concerned with internal logical structure of software. So, in the black box, that is a coding area is hidden and the work is done only testing is done on the basis of input and as per the output. This like this knowing that specified function that is in the software is designed is to check whether the work properly or not, and that include tests that are conducted at the software interface. Now here we are going to cover about white box testing. Now in the internal working, as you know in the black boxes we are now working the internal area of the software. We are just checking by the some corresponding input and output. Now the white box testing is the known as the knowing the internal working of a product and the test that all internal operations are performed according to the specification and all internal components have been exercised. Means here that the coding area where the all the lines of code to be need to test here that involve tests that concentrate on the close examination for procedural detail. That for the white box testing the person required to be the code as the level or the coding should require for the testing and the logical part through the software are tested and the test cases exercise specific test of conditions and loops to be tested here in the white box testing. Let's see in this session how the white box testing can be done much effective. White box testing that use the control structure part of component level design to derive the test cases. That controller structure means here check the coding and check the every level of the coding whether there is something error or not. These test cases are the guarantee that all independent parts within a module have been exercised at least one, and starting to end all the coding part to be tested one at least to check either they're working properly or not. It exercises our logical decision on the true and false side. जैसे कि आपको पता है कि हम कोडिंग के अंदर कंडीशंस डिसीजन स्टेटमेंट्स लगती हैं, लाइक इफ एल्स यूज होते हैं, स्विच केस यूज होते हैं, इनमें सम फॉल्स कंडीशन एंड ट्रू कंडीशंस आर एज वेल. So in this white box testing, we require to test all the condition items true and false. It execute all loop at their boundaries and within their operation bounds, and exercise internal data structure to ensure their validity. So their bugs are learned to consensus and congregate to the boundaries. Now about the basis part testing. The white box testing technique proposed by the Tom Cabby and that enables the test case designer to derive a logical complexity that measure of a procedural design. Procedural design is to by step is to check is there logically some mistake can be arise here that is to be need to test here, and it uses this measure as a guide for defining a basis set of execution path. Is check the path which is designed and in the check all execution paths are working correctly. A test case derived to exercise the basis that set are guaranteed to execute every statement in the program at least one time during testing is necessary to test. Flow graph notation. In the flow graph notation, they are checked from the data is flowing from the starting to end, and the all stages where the data is slow need to check, and here are the some notation are made for the graph flow. They use a circle for graph represent a node which stand for the sequence for one or more procedural statements, and a node containing a simple condition, that is expression, is referred to as predicate node, and that is a predicate node, and each compound condition in a conditional expression and containing the one and more boolean operator. So each represented by a separate predicate node. A predicate node has two edges that leading out from it is either true and false. That is the edge you can say that like a node consider where the condition asked to be checked is true and false. So it two node has out from the condition. So an edge must start and terminate at a node. An edge does not intersect or cross over the another edge. It is very necessary condition to be sure that in the graph. When counting regions, include the area outside the graph as region 2. Like here are saying that in the flow graph we use arrows, circles, area bounded by the edge that is called region, and the predicate nodes that we use here. Any procedural design program can be translated into a flow graph. Now we later discuss the flow graph can be analyzed by the various paths within it, and know that compound boolean expression at test generate at least two predicate nodes. This figure shows the flow graph we make designed by the previous slide. Let's the circle area from the state starting, and this is the decision box that can either be true and false. That you can say maybe false, and that you can say if true. If true, it by the condition 2, and it again check condition 3, true and false. According to the true and false condition, move to 6 and 4, and again to check So basically here diamond box symbol represents the decision box in which is taking the either condition is true and false. In this diagram, uh, like similarly we enter this last node, and this diagram shows some of the region are formed. Like this one is the region 1, region 2, region 3 and the region 4. Then required to test each region at least once, and the all paths from the beginning to end required to test here. Here are the many independent paths as well. Independent path that is to be tested here, that defined as a path through the program from the start node until the end node, that introduce at least one new set of processing statement or a new condition, that is a new node, and most that must move along to at least one edge that has not been traversed before by a previous path. These conditions are necessary, and the basis set of the flow graph on the previous slides are this. Path 1 is from 0, 1, 11. As you want to see, let's see here. The path 1 is from 0 to 1 and 1 to 11. Similarly, we consider all paths 0, 1, 2, 3, 4, 5, 10. 0, 1, 2, 3, 4, 5, 10 and 11. 10 and you can say this is the like this you can make many paths here. Next is here the number of paths on the basis determined by the cyclomatic complexity. Cyclomatic complexity basically the complexity give a quantitative measure of logical complexity. This value gives the number of independent paths in the basis set an upper bound for the number of tests to ensure that each statement is executed at least once. An independent path is any path through a program that introduces at least one new set of processing statement or a new condition. This is the about the cyclomatic complexity. This is more other point given here in front of your slide that provide a quantitative measure for logical complexity, and they define the number of independent paths as we seen previously, that provide an upper bound for the number of tests and must be conducted to ensure that all statements have been executed at least once. That can be computed three ways. The number of regions are made here. As in the previous slide, we studied the number of regions 1, 2, 3, 4, and we are here vertices of the graph, and E are the edges. We can calculate the how many number of regions can be formed in a graph by the easiest way of this formula. By this notation, you can write the total number of edge in the graph, total number of nodes, and that's to be a formula h minus node n plus 2, you will get the region. And then one more is that Vg is equal to p plus 1, and p is the number of predicate node in the flow of graph. The result in the following equation are the example flow graph that is taken the previous. Here the number of region 4. In the previous example we seen here the region of 4 nodes and the region of 4, and here taken the 14 edges and 12 nodes. Taken out the result is 4 region, from the other one also taken out the 4 region. Now the deriving the basis set and test casing, that is using the design or code as a foundation, draw as corresponding flow graph. So it check the code all the program to by the flowing the corresponding data from starting to end, and determine the cyclomatic complexity of resultant flow graph, that determine a basis set of linearly independent paths, and prepare test cases that will force execution of each path in the basis of the set. Let's see this diagram. In this diagram, there are the some paths that move again to back from the consider to this starting. The some nodes are removed because it shows that second flow of graph here to move by 10, and after 10 from the there the step move 5 6 8 and 10, it need to again move to 5. Some condition that come in the 13 that move to 5, and some condition move to 15 that can again move to 5. This code area is given from here. You can easily identify that how the code area move to again by step 5. Again here the simple function diagram that can easily analyzed by the help of code. Here the node number are given according to their the third step start from here until the 21 are taken here, and the each decision node and the are taken by the here the increment and decision loop. These structure are made with the help of this coding. I hope it will be very clear to you how to make this graph from the starting. Initialize to 0, it start with the here where the condition is less than in the y into y, take the decision 4. After 4 you need to move to 6, and where the condition is check, if condition is true, it move according to the 12 and 7th. If condition is true, it will move to the 12, and from 12 again check the condition move according to 15 and 13, and similarly here and this, and finally reach to 21. Next is the loop testing. That is a white box testing technique that focuses exclusively on validity of loop construct. They check whether the loop is valid for the true and false and check the constitution. 4 different classes of loop exist here: simple, nested loop, concatenated loop, and unstructured loop. Here the tests occur by varying the loop boundary values. For example is given here: loop boundary that is defined from I is equal to 0 to the I less than maximum of index value given here. So it check according to condition and move that value test here. Testing of simple loops are here that skip loop entirely and only one pass through the loop. 2 passes through the loop, m passes through the loop when m is less than n minus 1 and n plus 1 pass through the loop, and here the n max number of the above that you can pass. The similar testing of loop are made according to the number of m and n. Nesting of the nested loop. Testing of nested loop are the start at the innermost loop and that set all other loops to the minimum value. It conducts the simple loop test for the innermost loop while holding the outer loop at their minimum iteration parameter values, and it can add other tests for out of range of for excluded values. Let work outward conducting tests for the next loop but keeping all other outer loop at the minimum value and other nested loop to the typical value. So it continue until all loops have been tested here. Next is about the testing of concatenated, that is combination of other loop that for independent loop that use the same approach as for simple loop. Otherwise use the approach applied for nested loop. Here let's show that how can we make this flow path from the coding area. It take here from the starting to one condition that is into bottom 0 and start from graph area 1. See the step 2. It checking the while condition from here top to key position. So make here the step 2. Then we move to finally here if the condition false, it move to directly to the end. So the make condition here the 10. Next if true, it move to third. If a third move to be false, it again move to be 10. If condition will be true, it move to next if condition that is marked here 4. If again it is true, it move to next step, that is fifth. If condition is false, it move to this one statement that is marked here, sixth one. And the condition will execute and move to the state here, ninth. And the from here mark the true condition from the sixth one also. False condition from the sixth, that move to statement 8. And from here we can move 7 to as well as 9. And from 8 we can move to 9. And if the condition is the false, it moves to again directly to the step 2. So like this way we can make the graph complete here. Next is the creating test cases. Now in the software we need to make the all test cases to check whether the software is working correctly or not. Let us work out the number of distinct paths. Many of the distinct paths can be made here. Cyclomatic complexity here. For calculate easily number of edge minus number of node plus 2. That calculate the cyclomatic complexity here. And there are the list of distinct paths that can make here again from the loop as in the previous slides we done here. Figure that out the condition that cause execution of this path. These are the take this path. This 1, 2, 4, 6, 7, 9. As the loop again, it figure that out the condition and procedure and no transition start here again. You see able to see that 2 to 3, 3 to 4, 4 to 6 and 6 to 7 are the condition from bottom to top is true, and if key condition minus 1 will be true, false, and this true. These are related with the coding area. If you have clear about the coding, I hope it will be very clear to understand this step. And let's specify the separate input parameter to the create of this condition. Here the key values 10 the sequence take at the array list of here the R, and the key 45 the sequence are taken here. So this will be the sufficient for the path desired above. Now try to work out the flow graph of this code by the help of this method. This is the what I got here by this graph is the example. I hope you can try it by yourself and the result can be easily matched here. This is the exercise that you can do it by yourself. Explain the technique for testing. Explain the types of white box testing. This is all about of today's session. We are now winding up here. Thank you so much. Happy learning. We learn.